Hey, welcome back. So today we want to talk about, or introduce rather, the trigonometric functions in terms of the unit circle. And where do trig functions come from? They come from what I read on the internet, astronomy. So in particular, working with distances that are created by angles. So if you make an angle and you kind of open it up, what's the distance between the two ends of the terminal side and the initial side? Okay, so what we're going to kind of do is work with this thing called the unit circle, which is just a circle such that its radius is 1 unit long. Okay, so the unit circle basically just means the radius of the circle is 1. We'll standardize it in the xy plane, put its center at 0, 0, the origin. Okay. So here's a unit circle. We're going to kind of put these angles inside of here. So again, the positive x-axis is the initial side, and then we open up an angle to wherever we want, say right there. There's my terminal side, and we're going to call this angle, instead of theta, we're going to call it t. Okay, that's my cursive t. So this point right here on the circle, I'll call point P. And in general, it's given coordinates x comma y. Because it's a unit circle, and this point right here on the circle will be at 1 comma 0. But because it's a unit circle, the arc length, or the distance on the walking distance on the edge of the circle, so for us, this would be, for this particular angle, this distance right here, is just equal to the actual angle because of the way we've set things up with the unit circle. So what did I just say? Well, remember your standing room only formula. So S equals R usually times theta, but now we're using a T instead of theta. Because R is equal to 1, that implies that the arc length is actually just equal to the angle. Okay. So it makes things a little easier in that regards. So this arc length in red is S, but that's just equal to T. Okay. What else? The formula for this circle is x squared plus y squared equals 1. And now we're going to define the trig functions in terms of x's and y's, okay, on this unit circle. Okay, so the trig functions. There are 6 trig functions, and whenever I write them out in the notes, it's always going to be sine is the first one, and then I'll write cosine, and then I'll write tangent. Okay, those 3. So sin of t, these are all functions. Cos of t and tan of t. Okay, those are our first 3. And I will define them in terms of x's and y's from the unit circle, which is above. So let me rewrite my unit circle and put a point on here. So point x comma y. Okay, here is my angle t. Okay, so sine is going to be associated with y, the y coordinate. So all you have to do is kind of read off the y coordinate. Cosine is associated with the x coordinate. And then tangent is the ratio of sine to cosine. So we're going to put y over x. And of course, x can't be 0 for tangent. Okay. Then the other 3 trig functions, cosecant t, so CSC of t, then secant of t, and finally cotan of t. These are all just the reciprocals of the guys on the left. So it helps if you kind of always write out the trig functions in this way. So cosecant of t is just 1 over sine of t. In other words, in this case, 1 over y. Secant of t is just 1 over cosine. in other words 1 over x, and then cotan of t is just going to be 1 over tangent, in other words x over y. And again, we have restrictions on the variables so you don't end up with division by 0. Okay, so if somebody gives you a point on the unit circle, you should hypothetically be able to go through and tell me the trig function of that angle, that particular angle. Okay, so let's look at, this is problem 3 in the book. Okay. And our angle is going in the negative direction, so it's going to go down like this, and there's its terminal side. It's my angle T. Okay. And we have to figure out the 6 trig functions of that angle. So as always, I'm going to be writing it out in this way. Oh, and they give us a point on this circle right here. The point is radical 2 over 2, and then negative radical 2 over 2. Okay. Okay. Okay, so sine is the y-coordinate. So you look at that point P and take the y-coordinate. So it's negative root 2 over 2. Cosine is the s-coordinate, so that would be root 2 over 2. And then tangent is the ratio of those two. And you know, if you take negative root 2 over 2 divided by root 2 over 2, that's just negative 1. And then these other guys are just the reciprocals, right? So this would be 1 all over negative root 2 over 2, which is the same as 2 over negative 2 over root 2. And if you want to rationalize it, you wouldn't have to on my test, but you'll end up with negative 2 root 2 over 2, and then you could simplify that as negative root 2. Sorry. And then secant, same thing, but this one is just a positive version, so it'll end up being root 2. And then cotan will be 1 over negative 1, which is negative 1. Okay. Let's look at another one. So this is number 9. And they want to know what is the tangent of pi. Okay. So what we're going to do is find where that angle ends up at on the unit circle. Okay, so here again is our unit circle. Pi is 180 degrees, right? So our angle this time is just this. And here's our terminal end. And if we could figure out that coordinate there on the terminal side of the angle, we should be able to figure out all the trig functions of pi, right? So we start with sine of pi, and cosine of pi, and tan of pi, and then cosecant pi, and secant pi, and then cotan pi. And it gets sloppy. Usually I don't put in the parentheses, but sometimes it helps the reader if you put it in. Okay, so what is that coordinate? Well, if this is a unit circle, that coordinate is going to be at -1, 0, right? It's on the x-axis, so you know the y-coordinate is 0. And then because it's a unit circle, you know the distance from the origin to the edge of the circle is just 1. Okay, you know, I'm going in this direction, -1. Okay, so sine of that angle is just going to be the y-coordinate, so it's 0. Cosine will be the x-coordinate, is -1. And then tan will be 0 over -1, which is 0. Cosecant will be 1 all over 0, which is undefined, so we just put undefined. Okay. Secant of that then is the reciprocal of cosine, so it's just going to be 1 over -1, which is -1. And then cotan will also be undefined, because you can't have something over 0, right? As cotan is going to end up being -1 over 0. In other words, it's undefined. Okay. So ultimately, what then is the tan of pi? I guess I sort of did an overkill. The tan of pi just turns out to be 0. Okay. The domain and range of these functions, the input and the output. So if you've taken pre-calc, we've talked a lot about domain and range. We want to look at the domain and range of sine and cosine. Okay, you could kind of tell what they're going to be by looking at the x coordinates and the y coordinates on the unit circle. So first off, for sine of t, the angle, with regards to the angle, you can put any angle in there and figure it out, right? So you can have negative angles, you can put 0 in there. But in other words, the domain is everything, all real numbers. And interval notation, negative infinity to infinity. The range, then you're kind of looking at the y values, right? Because sine of the angle, the output, is always going to be the y values. And what is the biggest y value and what is the smallest y value? Well, on the unit circle, those 2 points will give you what you're after. Right? So the biggest y value is going to be the end of the range, 1, and then the smallest y value down here at -1 will give you the smallest number possible for the output. So at -1. Okay. And then likewise, you could play the same game with cosine. The domain of cosine, again, is going to be all real numbers. Okay, so the domain will just be from -infinity to infinity. And then the range, this time for cosine, you're looking at the x values, right? So the biggest possible x value will be over here to the right. It'll be 1. And then the smallest possible x value will be -1. It's about the output. It's weird because you always think that the x value is associated with the domain, but that's not how you're thinking here. Remember, the output of cosine is x, the x coordinate. It's okay. So the range, the possible, will go from -1 to 1, and including those endpoints. Okay. Okay. The next section we want to take a look at is our first kind of special angle, pi over 4. And we're going to have a bunch of these special angles kind of memorized. And we'll use those special angles to figure out pretty much any angle that we need, like the sine of 10 pi over 3. You'll be able to figure that out via these memorized angles. In this case, once you figure out all the trig functions of pi over 4, you could figure out like cosine of 11 pi over 4, tan of -95 pi over 4. The sky is the limit there. So anyways, if you remember, pi over 4 is 45 degrees or 1/8 rotation. Okay. And pictorially on the unit circle, where is that? It's right here. It's on the diagonal through the origin, right? So this is the angle we're talking about, where t in this case is equal to 45 degrees or pi over 4. Right off the bat, we can kind of get the point by noting that this is on the diagonal. So this point right here is on the line y equals x. Okay? So whatever you have for your x value, say it's a, you're going to also have that same value for the y value. You remember the formula for a diagonal line through the origin? It's just y equals x, and that would give you this diagonal. That turns out to be a 45-degree angle. Okay, so anyways, taking that a comma a, we could plug it into our formula for the unit circle, x squared plus y squared equals 1. Okay, so I could plug a in for x, I get a squared, plug a in for y, a squared, and then you could solve for a. Okay, so here's 2a squared equals 1, divide both sides by 2, and then a will be square root of 1/2, which you can rewrite as square root of 1, which is 1, over the square root of 2, which of course you can rationalize the denominator or multiply top and bottom by root 2. And you end up with root 2 all over 2. Okay. So the coordinate of that thing is going to be root 2 over 2, comma root 2 over 2. And then we can use that to figure out the sine of pi over 4, the cosine of pi over 4, etc. Okay. So I'm going to put cosecant pi over 4, secant pi over 4, and then cotan. Okay. Okay, so sine is just the y coordinate, which is root 2 over 2. Cosine is the x coordinate, which is root 2 over 2. And then tan is just y over x, so sine over cosine, in other words. And so that's just going to be root 2 over 2 divided by root 2 over 2, which is just 1. Okay. And then for the other ones, we just take the reciprocals. So cosecant of pi over 4 is the reciprocal of sine of pi over 4. And if you write that, it's 2 over root 2. But if you use this 1 over root 2 and just take its reciprocal, you'll see this becomes root 2. Okay. If you don't see that, taking the reciprocal of root 2 over 2 is 2 over root 2. And then if you rationalize, you end up with 2 root 2 over 2. And then the 2's cancel, and you just get root 2. Okay. So that's how we got that. So secant of pi over 4 is just the reciprocal of cosine of pi over 4. So that's just, again, that's going to give you root 2. And then finally, cotan of pi over 4 is just 1 over tangent of pi over 4. So 1 over 1 is just 1. Okay. So that's our first special angle. And, you know, we're going to have kind of memorize this for... and you don't memorize it, right? You just kind of, I know this one, I know this one, I know sine, I know cosine, and that tells you all the other ones because of the way that they work. So tan is just a sine over cosine, cosecant is just 1 over sine, secant is just 1 over cosine, cotan is just 1 over tan, right? So, okay, let's move on a little bit to even and odd functions. You may remember from pre-calc, even functions had y-axis symmetry, so this would be an even function. Odd functions have origin symmetry, so a cubic would be an odd function. The main kind of litmus test for this would be for evens, you plug in negative t instead of t, and if the output is just plain old f of t, then it's even. For odd numbers, if you plug in a negative t for t and you get out negative f of t, then it's odd. Okay? And we can kind of determine sine and cosine as to whether or not they're even or odd by looking again at the unit circle. So I begin with some angle t, right, located at this position, and its coordinates are x comma y. Okay? If then I look at negative t, which is just rotating in the other direction, its coordinate, because of the symmetry of the circle, is going to be x comma negative y. Okay? So if I just rotate downwards, I get this almost the same coordinate but with a negative. So let's see what happens. So what is the sine of t? Or rather the sine, we want to test to see if it's even or odd. So I'm going to put negative t inside. The sine of negative t. Okay, well, sine of t, if you recall from above, sine of t is just y. Sine of negative t, looking at this coordinate here, in this case is negative y, right? Negative y is just negative times sine of t, doing a substitution for this, right? So sine of t is equal to y, so you could plug sine of t in for y and you get negative sine t. In other words, sine of negative t is equal to negative sine of t. It's the odd relationship that we've found. Okay, so sine turns out to be odd. And then we can kind of play around and do the same thing with cosine. So what is the cosine of negative t? We recall that cosine of positive t is just x. Okay? If we look at the coordinate above, the cosine of negative t, the x-coordinate there is just x. Okay? So you put x here. And then doing a substitution in for x is equal to cosine of t. So we have cosine of negative t is equal to positive cosine of t, which on the left there is the even relationship. Okay? So it turns out that cosine is even. Okay? And then we could use this relationship to figure out the trig functions of more angles, more and more angles. Okay? So I just want to mention the other trig functions. It's noted in the book. I won't go in and show you why, but you could go through the same process and kind of figure it out. The ones that are odd are going to be sine of t, tan of t, cosecant of t, and cotan of t. And the ones that are even are just going to be cosine and cosecant. Keep forgetting to put a C in there. Okay? Okay. So a handy little chart to kind of remember. And you'll have to have that memorized for the test. Okay? Okay, so we can use this then to evaluate more angles. Okay? So in particular, the cosine of negative pi over 4. Right? So the cosine of negative t is equal to the cosine of positive t. So you could write, instead of cosine negative pi over 4, cosine of positive pi over 4. Okay? And then we know the cosine of pi over 4 from above, and we're going to have this memorized as well. The cosine of pi over 4 is root 2 over 2. Okay, so you may need to make note cards or flashcards and get it memorized. Okay. Let's look at another one, the tan of negative pi over 4. So tan is an odd function, so you can rewrite it by kind of factoring the negative out of the tan. It would look like negative tan of pi over 4. And then tan of pi over 4 is just 1, so we'll end up with negative 1. Okay, the video quiz for this section, I want to just put that in here. Find the sine of negative pi over 4. Okay. And that's the second video quiz. So again, you're going to collect the first 4 video quizzes on one piece of paper, take a picture of it, upload it to your computer, convert the PDF, and then send it to me through Blackboard. Make sure you label it and say video quiz 1, so I know what the heck it is you're sending me. Okay. Anyways, I've kind of been going on about tangent is sine over cosine. Let's make that more official, right? We did not give that its fair shake in our notes. So we'll label these as fundamental identities, which you need to have memorized. So basically, in my opinion, trig just comes down to memorizing about 2 pages of formulas. It's not too much, so don't worry. And whenever you use them, at least in my classes, I kind of remind you. Anyways, let's remember. So again, what is sine t? Sine of t we define to be y. And then cosecant of t we define to be 1 over y. Okay. So if you do a substitution, you see y is equal to sine, and just plug that into here, you get that cosecant of t is actually equal to 1 over, so this is via substitution. We see that cosecant of t is 1 all over y, which is sine of t. So you could do that with all the trig functions, and we get this kind of reciprocal relation amongst these guys. So we note all of these things. Sine of t. So first off, sine of t is equal to 1 over cosecant t. Cosine of t is equal to 1 all over secant t. Tan of t is equal to 1 over cotan t. And then cosecant t, of course, is equal to 1 over sine of t. So you kind of see how they relate. Secant t is equal to 1 over cosine t. And then, of course, cotan t is equal to 1 all over tan t. And also, by the way, tan t is equal to sine of t over cosine t. And then cotan t is also equal to cosine t over sine t. Okay, so you have to have memorized. Absolutely, positively, must memorize. So much to remember. Okay, so again, flashcards, something like that. So you have to have this memorized. We have to have the even and odd thing memorized. So this little thing here, odd and even, which ones are odd, which ones are even. You have to have the trig functions memorized for the pi over 4. So cosine of pi over 4 is root 2 over 2. It's good to know the domain and range. Okay. So let's look at an example from the book. This is number 25. They give you some information, and you have to figure out the other trig values for the particular angle. So sine of t is given as 8 over 17, and cosine of t is given as 15 over 17. Okay. And from there, you should be able to figure out tan, cosecant, secant, and cotan. So cosecant and secant, you just take reciprocals. In other words, flip the fractions. Okay. For tan, it's sine over cosine. So 8/17 divided by 15/17, which is the same as 8/17 times 17/15. And then the 17s cancel, and you have 8/15. Okay. And then cotan is just the reciprocal of that, so you just flip it, and you get 15/8. Okay. So it's a little time-consuming, but hopefully it's like riding a bike. Once you get on there and do it enough times, it'll become second nature. Okay. So there's one set of fundamental identities. The next identities are called the Pythagorean identities. Okay. And these are related to that equation of a circle that we first saw. Okay, so recall or note the equation of that unit circle, x squared plus y squared is equal to 1. And then also note cosine of t was defined originally as x, and sine of t was defined originally as y. So by substitution then, we could put those trig functions into the formula for the circle, and we get cosine t squared plus sine t squared equals 1. And that becomes the first Pythagorean identity. We usually don't see it this way. Instead of writing cosine squared like that, we could write it like this, cosine with a little 2 and the kind of exponent of cos. Okay. And then plus sine with a little 2 right there, like that. Okay. So, yes, you have to have this memorized as well. Cosine squared plus sine squared equals 1. Also, though, we can get more for our bucks from this equation just by dividing through by x squared. So what do we get there? If you divide through by x squared, you'll have x squared over x squared plus y squared over x squared equals 1 over x squared. That'll be 1 plus y over x squared. equals 1 over x. You could rewrite that as like that. And then we define those above, right? So we defined tangent to be y over x. And then we defined secant to be 1 over x. So tangent of t, secant of t. So again, we could do a substitution and get another formula. 1 plus tan squared of t equals secant squared of t. Okay, so here's one formula. And then there's another formula. And then you guess what? You can get a third formula by dividing through by y squared. So you could also take this guy and write x squared over y squared plus y squared over y squared equals 1 over y squared, which will give you x over y squared, which is cotan squared, plus 1 equals 1 over y squared, which is cosecant squared. Okay, so we'll have cotan squared t plus 1 equals cosecant squared t. And that's the third Pythagorean identity. By far, this one's the most important. So if you don't want to embarrass yourself at any big math gatherings, you must absolutely positively know this guy. This one I just put the little asterisk by. Okay. The other ones are kind of implied because you can always kind of just divide in order to get the other ones. This is the most meaningful one, but you are expected to kind of know these other ones if you know the first one, right? Because they kind of lead to the other two Pythagorean identities. Okay. Okay, so let's look at a problem where we apply this. We want to find the cosine of t, and in particular, we want this to be this angle t to be in between 0 and pi over 2, so 90 degrees. Okay, and we're given in this problem sine of t equals 6 over 7. Okay. Okay, so for this guy to get cosine of t, I'm going to use that Pythagorean identity. So sine squared t plus cosine squared t equals 1. And then I can do a substitution. So by substitution, I can plug 6/7 in for sine. I end up with 6/7 squared plus cosine squared t equals 1. 6/7 squared is 36/49 plus cosine squared t is 1. And then solve for cosine squared, get that all by itself, equals 1 minus 36 over 49 is the same as 49 over 49 minus 36 over 49. And so cosine squared t is going to be, it looks like 13 over 49. And then take the square root on both sides and get cosine t is plus or minus big square root of 13 over 49, which is the same as plus or minus square root 13 all over square root of 49. Square root of 49 is just 7. The cosine then, if you're stuck in that first quadrant, the output of cosine, because remember cosine of t is equal to x, the x coordinate will always be positive in that first quadrant. So if you're in between 0 and pi over 2 or 0 and 90 degrees, the signs of the x and y coordinates are both positive. So that means x has to be positive. In other words, cosine of t has to be positive. In other words, you don't want plus or minus, you just want the plus. So you'll say cosine of t is equal to root 13 over 7. Okay, so hopefully that makes some sense. All right. Okay, getting back to that idea of coterminal angles. So remember, if you have pi over 4 as your angle, so right here at pi over 4, you can get another angle that's coterminal to it by just adding in or subtracting 2 pi, right? So pi over 4 is coterminal with pi over 4 plus or minus 2 pi times any integer, right? In other words, if somebody throws something at you like sine of pi over 4 plus 200 pi, that's equivalent to sine of pi over 4. You can kind of just ignore the whole 200 pi part. And then, of course, from above, we know, or we'll eventually have memorized sine of pi over 4 is root 2 over 2. So in general, this holds, and it turns out that these trig functions are something called periodic. Okay? So periodic functions, given that we have this coterminal phenomena happening. If you have some point here for some angle t, sine of this angle t will equal to sine of this angle t plus some multiple of 2 pi. Okay. Sorry, one second. Yeah, so these guys are equal to each other. If you kind of think about cosine will work the same way. The only problem with this thinking is maybe you think then tangent will work the same way. It turns out tangent isn't going to work that way. So hold on. So cosine of t is equal to cosine of t plus or minus 2 pi k. In the book, they're not going to write it that way. They're just going to write plus 2 pi. But it's true for any multiple of pi. You can kind of just eliminate the 2 times the multiple of 2 pi. So again, you have to be careful, though, because if you deal with the tan function, and let's recall, what is tangent. The way we've defined tan of t is y over x. Okay, so if you go tan of t plus some complete rotation around the circle, you may be kind of well, I guess you'll be right back where you started, but look, if you just go by a multiple of pi, like 1 pi, here's where we start with our point x comma y, and then if you rotate 90 degrees, because of the symmetry of the circle, you're going to have the point negative x comma negative y. So if you say then it's negative x over negative y, you end back up with a negative over negative is a positive, and you end up back with y over x, which again is tan of t. So for the tangent and the cotangent, it's periodic, but not in the same way as cosine and sine. Okay, so hence what you're going to see in the book for tangent and cotangent is this. You'll see tan t equals tan of t plus pi, or any multiple of pi. So we could say plus or minus pi times, what letter did we use? K. And then cotan is the same. So this would be cotan of t plus or minus pi k. And of course that includes the even values as well. Okay. Okay, so some examples then from the book, where this is what you're going to be tasked with doing. Evaluate the tan of pi over 4 plus 15 pi. Okay. And as long as it's a multiple of pi, you can kind of just cross that part of it out and rewrite it as tan then of pi over 4. From above, tan of pi over 4 is just 1. Okay, so you end up with -1. Let's try to 50. We have the sine of negative pi over 4 this time minus 2,000 pi. And in this case, it has to be an even multiple for you to throw it out. So you throw out this part, and you end up with the sine of negative pi over 4. And then because sine is odd, you could take the negative and put it out front. So you get negative sine of pi over 4. And then, of course, sine of pi over 4 is root 2 over 2. Okay. Let's see, what else do we have? And that's about it. Let's get into some WebAssign then, or MyMathLab is what we're using. And see what we have there. Okay. So I just finished my office hours. Nobody came. Come see me during my office hours. Let's go to the homework. And it's waiting for me. 4.2. It seemed like I already had it open. But okay, whatever. 4.2. Let's skip ahead to maybe some of these harder ones, like 28. Oh, maybe we're not ready for that one yet. Let's go back a little bit. So using your calculator to figure out the answer. Make sure you're in radian mode to figure out 4 pi over 13. So just very quickly, sine of 4 pi over 13. You wouldn't be able to do this by hand. They actually say use a calculator to do it. Some of them you gotta figure them out by hand. Sine of 4 pi divided by 13. And let's make sure I'm in the right mode. So you have to be in radian mode, not degree mode. So, and it looks like about 0.8230 radians. Okay. Let's get this leveled out. And there we go. 8230. Yay. These ones are kind of weird. Let's do one of these. They'll give us 10 cosine of negative t minus cosine of t. And they're saying let sine of t, which we don't need, is a, cosine of t is b. And then they want you to write your answer in terms of a, b, and c. Okay, so you're going to use the even odd identities for this one. Cosine of negative t is equal to cosine of t because cosine is an even function. Right? So that's equal to cosine, 10 cosine of t minus cosine of t. And then do your cosine of t is b, so it's 10 times b minus b. 10 b's minus 1 b is 9 b's. Okay, so you just have 9, I guess, times b. See if it likes that. Okay. And then this is a harder one. Sine of negative t minus 4 pi minus cosine of negative t minus 6 pi minus tan of negative t minus 7 pi. And of course, sine of t is going to be a, cosine of t is b, and tan is c. So this is using the periodic properties of sine and cosine and tan. For sine, you can kind of eliminate anything that's added in that's a multiple of 2 pi. So we end up with sine of negative t for the first one, minus cosine. Again, we can eliminate any of these parts. So it's cosine of negative t there. Oops. And then minus negative t minus 7 pi. So it's a odd multiple of pi, or any multiple of pi. You can eliminate, and you get minus tan of negative t. And then use the even odd properties. So sine is odd, so this would be negative sine of t. Cosine is even, so it's still negative cosine of t. And then tan is odd, so negative negative, which become positive tan of negative of regular t now. And then you have negative sign, so doing substitutions, negative a minus cosine is b, and then plus tangent, which is c. Let's see if that's what it is. Negative a minus b plus c. Okay, so we got the hard ones out of the way for you. And maybe let's just do an easy one here. Use the unit circle to find the value of cosine. So these are using points to evaluate cosine on the unit circle. So remember, cosine of t is equal to x, the x coordinate. So negative 3 pi over 2, negative 1 pi over 2 is right here. Okay, so let me draw the unit circle. Negative 1 pi over 2 is here. Let me put it in red. Here. Negative 2 pi over 2 is right here. Negative 3 pi over 2 is right here. So the point we want is 0, 1, and that means cosine of that angle, negative 3 pi over 2, must be 0. Okay. So we can put in 0. And is there any more? Cosine of negative, oh, the first one was cosine of 3 pi over 2. Sorry. I got lucky there. They're cosine, they're both 0, aren't they? So cosine of 3 pi over 2, where would that have been? 3 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. The coordinate at that point would have been 0, negative 1, but the x-coordinate is the same for both of them, so that's how I got lucky, and I got 0. Negative 3 pi over 2 then is also 0, just using the point and noting cosine is equal to x. Okay. Yay. Okay, so we'll let you go at that, let you go at it, and hopefully you'll be okay. As usual, thanks for watching, and we'll see you next time.